Okay, so on this question, it's a quick little review on domain. We've had domain before. So how do we find domain? Well, it's given us three cases: a fraction, a root, and then a natural log. That's what LN stands for, is natural log. So let's go down. This is the notes. This is the exam 3 notes. And here we go, finding domain. So, so I'm giving some examples. Number one, if the denominator does not equal 0 and solve for x. So you take the denominator not equal 0 and solve for x. Or number two, the inside of a square root. So what do we have here? Oh, this one we have denominator. We don't have any, so on first part here, we have a denominator, don't we? Denominator. So when you have a denominator, this is over here, denominators cannot equal 0. Whenever you're doing the domain is all about what the x values are allowed to be. What are the allowable x values? What are you allowed to plug in to this function? Like what are you allowed to plug into a microwave oven? A microwave is a function. Well, you put in anything you want, but you shouldn't put in metal, tinfoil, things like that, forks and knives that are metal, because it'll spark, right? So metal is not in the domain of a microwave. The domain is everything but metal for a microwave oven. So domain is allowable inputs. What are you allowed to plug in? And therefore, if you have a denominator, you're not allowed to plug anything into the denominator that makes it 0. Remember, because if the denominator becomes 0, that becomes infinity. Like 3 over 0 is actually infinity, because 0 can go into 3 an infinite amount of times. So we don't want infinity. That's not a number. So we don't want that. So we say you can't plug anything in. Like in this one, you can't put in 3 to the denominator, because 3 minus 3 would make that denominator 0. And anything divided by 0 is infinity. So denominators cannot be 0. So we say denominators, there it is, you cannot be 3. So that's what we do here. We say, all right, denominator, over here, denominator cannot equal 0. So 3x plus 1 cannot be 0. Subtract 1 from both sides, boom, boom. This is a not equals equation. It's just like an equals equation, except it's not equals. And then divide by 3. Boom, x cannot equal negative 1/3. X can be anything in the world you want, but you can't let it be negative 1/3. Well, how do you give that as an interval notation answer? Well, what you do is you say, I'm going to draw a number line here for you. You say anything on the number line you want, but you put an open hole at negative 1/3. You shade everything to the left and everything to the right. You're saying everything except there's a hole been drilled out at negative 1/3. So you can go from negative infinity up to negative 1/3 and from negative 1/3 to positive infinity. So you would say it's negative 1/3, negative infinity up to negative 1/3, united, parentheses, with negative 1/3 to infinity. So that's a way of saying everything except x cannot be negative 1/3. What? Because negative 1/3, if plugged in for x, will make the denominator 0, which makes the whole function infinity, not a number. We don't want that. So we're saying you can be any number here from negative 1/3. From negative infinity to negative 1/3, or you can be any number over on the right side from negative 1/3 to infinity, right? This interval is the right side. This interval is the left side. You always do left edge, right edge, left edge, right edge. Parentheses, because you're not touching those numbers, right? Did you catch that? Not a bracket. Parentheses here. Why? Because you don't hit the negative 1/3 right on. That's the whole point. You can't be negative 1/3. You can't touch it right on. And then the negative infinity, you can never be at infinity, can you? So the infinities are also parentheses. So that covers every number except negative 1/3, because it never touches negative 1/3. All right, next part. Let's grab it. right here, domain. So what do you do with the square root? Well, it says inside of a square root greater than or equal to 0. So the inside greater than or equal to 0, which means 3x plus 1 greater than or equal to 0. Why? Because you can't have a negative in the square root. Remember, that's imaginary. Square root of -9, for example, your calculator will tell you error. It's imaginary. So we can't let the inside of a root be negative. So we're saying, just like we can't put metal in a microwave oven, we're saying inside of a square root must be greater than or equal to 0, meaning positive or 0, right? Greater than 0 is positive, or equal to 0. It can be 0 or positive. It can't be negative. So, okay, solve then for x. Subtract 1 from both sides. Boom, boom. And divide by 3. Boom. So x is greater than or equal, I think I made that too well. Greater than or equal to -1/3. X is greater than or equal to -1/3. How do you do that on a number line? Well, you go -1/3, bracket, and go to the right, which means infinity. See what I did there? It's a bracket. Now, why is this one a bracket right here? Because it's straight on -1/3 equal to, greater than or equal to. You can be right on -1/3 all the way up to infinity. That's the left edge, right edge, we would say. -1/3 to infinity. Parenthesis at the infinity, because you're never right on infinity. And bracket at -1/3, because you're straight on the -1/3. You're equal to the -1/3. Greater than or equal to the -1/3. You're straight on the -1/3 or bigger. That is the interval answer. That's another way of saying greater than or equal to -1/3. And then the final one is this one here. Let me grab it. Bring it down. Draw a line for us here. A line in the sand, so to speak. So we're saying, what does it say for that? So going to the notes. So come on, notes. We did the denominator not equal to 0. We did the inside of the square root greater than or equal to 0. And then skip, we don't have both. 4, inside of a log or natural log. Okay, so here's our log. The inside must be greater than 0. So if you have the inside, you set the inside greater than 0 and you solve. That's us. So I've got to say inside greater than 0. What's the inside? What's the 3x plus 1 greater than 0? 3x plus 1 greater than 0. Because that's the inside of the log. Solve that equation. Subtract 1 from both. 3x greater than -1, bring it over here. 3x greater than -1. Divided by 3. X is greater than -1/3. How do you put that on a number line? Let's do it. So -1/3 to infinity, right? Greater. Parenthesis right there. Right, because x is greater than -1/3. So there's a parenthesis at -1/3, not a bracket, all the way to infinity. It looks a lot like the last answer, you see. The only difference is we have parenthesis there instead of a bracket. Why? Because you can't equal -1/3. See, it says greater, only greater. So remember, parenthesis means you're around the number. It's rounded. You're around -1/3. You're close to -1/3, but you're not right on it. Whereas this one's a bracket. It's got a straight edge. You're right on it because you're equal to -1/3, greater than or equal to -1/3 for the inside of the square root. Why? Because the inside of a root can be 0. You can be greater than or equal to 0. It's okay to be 0. But the inside of a log, it can't be 0. Yeah, the reason we have this requirement, you might wonder, why do we have it must be greater than 0. If you try taking the log of it, try to calculate one, ln of whatever, -2, or regular log of -3 or -1 or whatever, both those will give you an error. You can't, and also if you put in 0, ln of 0 or regular log of 0, all these will give you error because you can't put 0 or negative inside of regular log or natural log ln. They're all not going to work for 0 or negative. So that's why we say the inside must be greater than 0, not equal to 0, which is what we had for inside of a square root. The inside of the square root can be 0. It's okay to take the square root of 0. That's just 0. But it's not okay to take the ln of 0. That's an error. You can try it in your calculator. You'll see. So the inside of a log must be greater than 0, not equal to 0. And the inside of a square root must be greater than or equal to 0, because it's okay to be 0 in that case. So we go back and we say, all right, that's what happened. That's why we get a parenthesis at the negative 1/3 instead of a bracket. Otherwise, it's the same. So there's our review of domain.